Good day to all. In this video, we learn about the system structure. We have four types of system structure. The first one is simple system structure, monolithic and layered approach, and finally the microkernel system. What is simple system structure? In the system structure, all the components has been divided into modules. So all these modules are, for example, modules means application program, resident system program, MS-DOS device drivers, and the ROM BIOS device drivers. These modules has been assembled in the layered format. So in this layered, all modules has been interact with the adjacent and also the next level of the modules. So in this module, the application program can access the resident system program and also the ROM BIOS device drivers. For resident program system, we have the access the device drivers and also the ROM BIOS device drivers. So device drivers can directly access with the ROM BIOS devices. So in this section, all the programs, all the modules can access directly to the kernel. So this is very complicated and very difficult to manage the kernel because of all the application, all the user can access the kernel means it will affect the operating system core. So this is not not a safety operating system. The MS DOS is the example for the simple structure. So for we have to avoid these problem, we move to the next level of system structure that is called the Unix system structure. It's called the monolithic structure. In monolithic structure, it will be used for the uniprogram or uni-use, a single user system we can use for these type of operating system structure. So in this Unix system structure, and limited by the hardware functionality, the original Unix operating system had limited structuring because of it has two separable parts. First one is system program, the second one is kernel part. It provides the file system, CPU scheduling, memory management, and other operating system. In monolithic structure, it is a very basic OS in which file management and memory management, device management, and process management are directly controlled within the kernel. The kernel can access all the resource present in the system. In the system, each component of the OS is contained with the kernel. It is also known as the monolithic kernel. It is an old OS used to perform small tasks like batch processing and time sharing task also. It controls all the hardware parts. The entire operating system is working in the kernel space. The execution of monolithic kernel is quite fast as the services such as memory management, file management, and finally process scheduling. If any one service fails in the monolithic kernel, it leads to failure of the entire system. This is the very big disadvantages of that monolithic system service. The entire OS needs to modified by the user to add any new services. So avoid these types of problem, we move to the next type is called the layered approach. In this layered approach, in this system that is divided into number of layers. So each build up of on the top of lower layers. So the bottom layer is the hardware and the higher layer is the user interface. The advantages of this layer approach is called the modularity. So each layer use the function and the services of only and low level layers only. And that simplifies the debugging and the system verification also. So when the debugging is performed starting from the lowermost layer, any error found during debugging of the particular layer must on that layer only as the layers below it and already have one debug. So this difficulty in this approach is divided into the system into appropriate layers and deciding the position of the layer with respect to the one another. So avoid these types of problem, we move to the another one type of operating system structure that is called the microkernel system. Microkernel is not it is nothing but it is a small kernel. In 1980s, the Mellon University developed an operating system called MAC, that is modularized kernel, using the microkernel approach. This method structures the OS by removing all non-essential components from the kernel. The result is a smaller kernel that is called the microkernel concept. So a microkernel is divided into two parts. The first one is kernel space and the second one is user space. Both these two parts communicate with each other using the interprocess communication method, using the message passing and the shared memory communication. So the main function of the microkernel is to provide the communication between the client program and the various services are also running in the user space. So while we have to access the kernel space, we can use the message passing method. We can communicate with that. It's a very nominal and a very useful operating system structure for our microkernel. Is the best operating system structure. Thank you.